Morning, my dear kids. I'm Sridhar, your physics teacher. In today's class, we are going to start the new chapter called as the vectors. So it is like one more like how the basic math is very important. Similarly, this vectors also something almost in every topic we are going to encounter. The same thing you are going to carry on in the mathematics like a vector algebra. Here we are going to call this particular topic as a vectors. We'll deal with a simple vector algebra, not the 3D or higher level, and one which is very much essential for our physics and what is the significance of it and how to use it. So these things, these aspects is what we'll be stressing. So this entire chapter, like first we'll start with the definition of vectors, types of vectors, then we'll go for the representation of vectors, then addition, subtraction of vectors, the resolving of vectors, dot product, cross product. Then the vector applications, what all we study, how we are going to use in the various parts of physics. These things is what we are going to analyze in this particular chapter. Today we are going to focus on the definition and types of vectors. Let me start the class. Okay, I have brought on the left hand side, you can see the diagram. The very diagram, I could have directly started writing the expression and okay, vectors, okay, this one. But this is this diagram is something which you try to look at. You go to any application, you do mechanics application or so like anything the engineering, there the idea of vectors will be involved. They're very simple, like when we catch a fish, there's a machine, there's a motor. Using this, we can easily lift, or we can like a mesh which contains all the fish, we can easily lift it with the help of this. And these are the supporting beams. Here what happened, we use some laws of vectors, some rules of vectors to design all these things. So to just go for the engineering mechanics, no, you do get everything based on the diagrams of these kind of applications. It's a very, very essential things which is going to help us a lot in studying the physics in a very scientific way. That extent, this particular chapter is having an influence on the physics. Okay, let me begin. So we will begin like this. So actually, if you look at the universe, in the universe, we do have quantities will get. And what we deal with the physical quantities. What do you mean by physical quantity? Which can be measurable. Means, so only the physical quantity means which we can measure and we can express in certain units, then only you can call that physical quantity. There are some quantities which we cannot measure, like a respect, the discipline, love, affection, the fear, emotions. We cannot express them. Therefore, so we don't call them as like a physical quantity. So only quantities which can be measured is what we call it as physical quantity. This physical quantity you can categorize into two parts. One, scalars. The other one is a vectors. So this particular scalar, so what are the features of it? Like, will have or having only magnitude and no direction. So physical quantities having only magnitude and no direction, we'll call them as a scalars here. So example of that: distance, mass, speed, energy, the speed, then the next, the energy, temperature. So all these are the density. They will not have any direction, only the quantity, no, only the magnitude is what they'll be possessing that one. That is about the thing. Okay, what are the features of vectors? Having magnitude, having direction, obeys law of vector addition. Okay, these are all the primary features of a vector. So what are the examples? Like, is there any quantity, physical quantity, which are related to this? As we do have physical quantity. First, we'll start with the displacement. Velocity, force, displacement, velocity, force, momentum. We do have torque. All these are physical quantities which will obey the law of vector addition. So like this is, we'll categorize this one. And then, so what is the, sir, what is the use of learning? Okay, till now, what all you learned. So suppose a mass, how to add, suppose like a 2 kg block is there. 3 kg block is there. I'll ask you to add these two masses. What is the total mass? M1 plus M2. Then you're going to write 2 plus 3. Total mass is 5 kg. So what actually it is, we are doing some sort of mathematical operation. What is that operation? I think it is a algebra. Till now, the algebra, what you know, how to add the two quantities, how to subtract, how to divide, multiply. These are the things what already we know. The algebra, the scalar algebra, what you can say, like the maths, what we know, how to add two scalars. Yes, we know it. How to add 2 plus 3, we know it. How to subtract, how to multiply, how to divide. Yes, we are well aware of the mass involved with the scalars, because they possess only the magnitude. What all the maths till now you have come across, the algebra, what you can say, it's all about the scalar quantities. We were dealing with scalars. Now, how to add two quantities which are having magnitude, how to add quantities which are having magnitude as well as direction. Only magnitudes we know, that all the mass, what also, suppose like I'll ask you the like a energy, like a body is having energy, one body is having E1, the difference in energy. The difference in energy, 10 joules minus 6 joules. How much will be 4 joules? So can we subtract two scalars? Yes, we know. Can we divide, can we multiply scalars, two scalars? Yes, we know it. So we are well aware of all the types of that. Suppose a density is equal to mass by volume. Mass is 10,000 kg. Volume is, say like a 5 meter cube. So then how much it will be? 200 kg per meter cube. So what type of mass here? You can see that this was the difference is what we took. Here what we are doing, we are dividing it. Similarly, can I go for the multiplication? Similarly, the multiplication also we can do it. We can also go for multiplication, mass equal density into volume. So all these maths we know it well aware.
Because the reason for that, because we are able to do this mathematics, we are able to add masses, we are able to take the difference between energies, we are able to divide mass by volume, because there's no direction involved, and it was very easy. All this scalar mass dealing with scalars was very easy. Now, how to add two quantities which are having, so like a magnitude and having a direction, how to deal with vectors? There's a primary question we are asking ourselves. Sir, how to deal vectors means here also I'm going to go for the similar way. No, the primary, can we do the similar? Two vectors shall we add? The way we had it like a scalar? Definitely the answer will be no. Definitely the answer will be no, that one. So any reason for that? Okay, we will take the example like this. Suppose say if I have a box, I think these are the block, I'll put it. There's some bag, you put it. This will be much familiar for you. No. So first I'll pull this with a force of say like a 12 Newton. Then I'll pull this with a force of and also pull with one more force, so like a, let it be of 4 Newton. Now, what is the net force acting on this box? So the net force, what we are going to add up is like a, both the force acting in same direction. So I'm going to add up 12 plus 4 will be 16 Newton. Then similarly, I'll take the, let me choose let me keep a box. I'll apply force F1 and F2. So here this is 12 Newton, 4 Newton. This is some sort of box, bag or box, anything you can put it. It's your convenient. I'll take another box here. So some box I'll keep it. Then what is the net force acting on it? We are going to say that F1 minus F2. 12 minus 4, this will be 8 Newton net force. Instead this, can I take some block where I'll apply force F1 equal to say like 8 Newton, F2 equal to 4 Newton. How I'm applying force, you see in this case, how that forces are applied. This force is acting along. Let me just shift it down. Yeah. This force is acting along x-axis, this is along y-axis. Now I think here the trouble starts. What is the net force means what you are going to write. There's a scalar, what all we discussed. So here the net force, in the third situation, the net force you are going to write. Let me come to the net force. In the third situation, what you are going to write. F1 along x-axis plus F2 which is acting along y-axis. Even you have to consider the direction. You can't write 8 plus 4. So what is this? This is the magnitude of 8 Newton is acting along x-axis. Magnitude of 4 Newton is acting along y-axis. Now you see this. You can't just write 8 plus 4. Even you have to consider this x-axis. How to add x-axis plus y-axis? There's a biggest headache now. This is the biggest headache is what we have encountered now. And what is this? There's a net force we are supposed to calculate. 8 plus 4, okay, we can do it, but how to add x plus y axis? So definitely we don't know maths. We don't know how to add a quantities which are having directions. Will you ask yourself this question? In the third diagram, okay, this was the first diagram, no problem. Second diagram, no problem. Third diagram, what is the biggest headache? We don't know to add a quantities which are having directions. Are you getting the idea? This is the primary question we are asking to ourselves. How to add these two forces because they're having magnitude and direction. So what do this 8 Newton? Magnitude. What about this? Indicates direction. Able to get this one. So definitely there is something what we don't know. And what we don't know. We don't know how to take how to add two quantities which are having the direction, and for that purpose we have to design a mathematics. That is what we are going to call as a vector algebra. So what is the biggest thing here now? Looking at this, we don't know, or we means especially let me call I don't know how to add two physical quantities that are having directions. There's a primary question. So who will answer this? How to know this one? Vector algebra. Yes, by using vector algebra, we can add two quantities which are having direction also. So what are the rules of the vector algebra? A new math is what we are going to learn. That particular mathematics is what we are going to call as vector algebra. In vector algebra, we are going to learn the addition of vectors, subtraction of vectors, multiplication, splitting of vectors. So all that is what we are going to learn here. So can you say, sir, anything about the net force? As the net force is somewhere in this direction, it will act. So primary question, how much, what angle it will act, all these things are to be determined. No? All these things can be answered by designing, by following the rules of vector algebra. So slowly now we have introduced, we are entering ourselves into the basics of vector algebra. Got there, all of you? Yeah, these are the things. So you just go in your home, there'll be bag will be there, some box will be there, there'll be some block will be there, anything. So you try to pull in the, you simultaneously pull along X and Y. It will try to move here. So what is this resultant force? Okay, with the till now what all we know with the scalar, like a mass that was dealing with scalar quantities cannot explain you how to calculate this F net. So a new mass has to be brought into the picture. That's what the vector algebra. Okay, let's get into this one. So I was saying about vectors. So how do you represent? So scalar we know. Suppose a mass is equal to 9 kg. This is quite easier because there's a scalar. No, we know how to represent a scalar quantity. 9 is a magnitude, kg is a unit. If I write 9 kg, so this is the quantity, physical quantity. What is the 9? The number 9, or select, I'll put it 8. The number 8 is a magnitude. There's a unit. Okay, this one, like this here. So there's no problem with the expressing scale. How to express the vector, or for that we'll call it as a representation of vectors. Let me start this one. Representation of vector. How to represent means a vector quantity is there. How to show that? The method is very simple. Just bring one arrow. Here, if I write this is A bar, so this is AB. So this is the head of vector. This is called as, this end A is called as tail of vector. Let this be the some force F bar. So what is F bar is equal to, we do represent by symbol or AB bar. So what do the magnitude represents? The length AB indicates magnitude. Length AB indicates magnitude. AB bar, or you can write also just AB bar, or we can also write it as F bar equal to AB bar. It's not that compulsory that this arrow has to be indicated. There's also one form what we use here. Now the vectors, it will be this is F1 bar, this is F2 bar. So look at that one now. Length AB indicates magnitude, means this particular length of the line, length of this vector will indicate the magnitude. So which is having more length, this having more length. So therefore I can write the magnitude of force F2 is greater than F1. This is the one representation of a vector here. So why do we brought this? What is the use of this representation of vectors? See, every time, suppose say if you have, I don't want to give a bookish explanation. So that one, so suppose I will directly take one example. I do have a blog. I don't want to dump with unnecessary literature here because it is a physics. No, directly will take. There's a blog. You are pushing it. What you are trying to do, you are you are trying to push the block, no? So every time, and by pushing, what you are doing, you are applying some force. Every time drawing this person, saying that is applying force horizontally, because force is a vector. So we put it in a very systematic way. The representation vectors is what going to help us a lot. The representation of vectors will come. So here, instead of this person applying a force, no, we just show that we'll bring a vector like this. Tell me, like in studying things, when we are studying this one, so the person was applying, the person was pushing with block with a force of 10 Newton horizontally. I'll just put in a very simplified way, 10 Newton, and that arrow indicates the length of that one. So here I'll say that person was pushing the block with a force of 10 Newton horizontally. This everything has become a very simple way, just showing the force. So what do this length of this vector indicates? The magnitude. If it increases force, I should increase the length of this vector. I think every time all will not be artist. Everyone cannot draw the diagrams like this. So this will be much easier, no? So therefore we go for the representation of a vector. So therefore, what is the one more conclusion? This called like a tail, this is a head of vector. The distance from the tail to head of vector will become the length of the vector. The length indicates the magnitude of vector. Length AB indicates magnitude. Then if there are two vectors of different length, what does it mean? They are having different magnitude. They can have same direction. What will be that one? And you look at this, the orientation also, you check it once. Look at the orientation. this is making some angle 30 degrees. This is making angle 20 degrees. So they are oriented in different direction. So like that, whenever you take this vector, it is having the length will indicate magnitude, and you see that it is making some angle. So it's having some direction also. Here is applying force horizontally, it's having some direction. Like this, we brought the representation of a vector. Okay, then after this, okay, when defining a vector, so we do have some essentials and selective factors. The first one, essential. If you take the any vector, that these are the essential. They must satisfy this one, magnitude. So what is this? This is the distance between points A and B. And then one is the direction. So what is the direction of arrow directing from B to A? Directed from point B to, so directed from point, I will write it in detail, from point A to point B. What actually this is, I'm putting something very fundamental here. Now, if you see this, this arrow will indicate the direction of this vector, and these are the points A, this B. This length will indicate the magnitude, and this arrow will indicate as that vector is directed in this way. It is having this particular specific direction, or it is making angle 30 degrees, or making an angle theta with horizontal. This arrow will indicate the direction. These are the essential. You take any vector, these are the essential. Now there are other features also will be there. So these will call it as a selective factors. Just only the different types of vectors we can classify easily with the help of this one. The next one is point of action. Second one is the line of action. So what is the use of this? We can select, okay, what is the use of this one? Point of action, line of action. So again, we'll take the we'll take two examples. Now let there be a box. Now I'll apply force at a certain point. Say F1. I applied at certain point here. There's a box. Then what is a box? It is having a tendency to get shifted. So after some time, it will come here. It got under the box will start moving. Then in the second situation, I'll apply force at such a point where instead of moving, let me put this as rough. I applied a force, but look at the point here. Here I applied at point P1, and the second case I applied a force at point P2. Now instead of moving, the box what happens, starts tilting. Tilting, how to show? Okay, it starts tilting. It starts tilting means topple. able to understand, it starts toppling. So what does it mean? So now you can see that where you apply force also matters, no? Where you apply force also matters. If you apply force at somewhere at the top edge here, it will tilt. If you apply force somewhere, it will move. So therefore, the point of application also matters here to define this particular force. Force is a vector quantity, no? Now I'll give one more example. Like you might have come across the rods. So if I have a rod suspended, both these rods are suspended. Now I'll apply force in this direction. Anything will happen to the rod. It will not rotate. The rod, am I right? Now if I apply force like this, the rod starts rotating. Rod starts rotating, rod rotates. It starts swinging. I think everyone knows, like it starts swinging here. So it's not understanding. I'll bring it here. It will start swinging. If you apply force, it starts swinging here. I'll bring with other color. Yeah, you can see now. Oh. No. If I apply force, it starts swinging like this. It starts moving in this particular case. What about here? Here, if you apply force, nothing, the rod will not move, will be there only. So what is the reason for that? Because the way you apply the force at such a point that the rod cannot rotate and it cannot move because it is hinged here. It is hinged here. At this particular point, there is a hinge. The hinge will not permit for the rod to move up. Here it rotates. So where you apply force also matters. No, see, this force is having magnitude, direction, and also you are applying the force at some specific point. Here it produces rotational effect. Here no rotational effect. So point of action also matters here, or the point of action or point of application also matters. Able to analyze here. So this particular thing, so what we call this as like a we'll introduce one more word called as a line of action. So this particular line is called as, here also we can introduce a line of action. So the line of action also matters. Here you see that one. It is perpendicular to line of action. So it is not producing any rotational effect. So like this, even for some vectors, along every vector will have this magnitude direction. Here what will happen, these factors will help us to define that quantity still more systematically. So like this force will just only make the body to move. Here this force will make the body to rotate. Why it will rotate? Oh, you applied such at one specific point. Why it will rotate? Because of some line of action it is being followed. So like this, what happens? We can further study the force, or we can study the physical quantity still more perfectly by bringing these selective factors also. Okay, now we'll go for these are about the very basic fundamental things about the vectors. We'll go for the types of vectors. Now, before going for any vector algebra, first we should come across what are the different types of vectors are there. I think for this, we'll just take help of the arrows, the different colors. I have a vectors. There's a A bar, this B bar. That they can be oriented in different way also. This is A bar. This B bar. It can be oriented in any direction. It's not that they should be like horizontal, then they'll become equal vectors. So here, look at the length A bar and B bar. Both are having same length, both are having same length, and both are having same direction. So therefore, they'll become equal vectors. The first one we are bringing is equal vectors. Here, this will make 30 degrees. This also make 30 degrees. Vector P bar, vector Q bar. A equal to B, P equal to Q. And also here A bar equal to B bar, here P bar equal to Q bar. So how you define the equal vectors? Two vectors of equal magnitude and direction are said to be equal. If two vectors are having equal magnitude and same direction, they're said to be equal vectors. So there's one primary definition is what we can put it, are same direction are said to be equal vectors. I'll complete the sentence, are said to be equal vectors. Okay, fine. Next again, the unequal vectors. So there's a vector. There's a vector A bar. There's other vector B bar is there. Or there's a vector A bar. So the other vector of same length but different direction. They're having same length. or we can put it like a vector A bar. The other vector is the direction is different and also the magnitude is different. Okay, no, first we'll take it. There's a A bar, B bar. What is the thing? Having same direction but different magnitude. These two. A not equal to B. What about here? P bar, this is Q bar. P equal to Q, but the directions are different. Magnitudes, same direction, but different magnitude. Same direction with a different magnitude. What about here? Different directions and different direction and same magnitude. This P and Q will become unequal vectors. Here, look at C bar and D bar. Different magnitude, different directions. Different magnitude and different direction. So a vector, if they're having same magnitude, different direction, or different directions, same magnitude, or different magnitude, different direction, they are said to be unequal vectors. I'm maximum trying to explain through diagrams, so rather than just blindly omitting the definitions, they will not help in physics much. After this, we'll go for the negative vector. There's a vector A bar. The other vector, I'll bring it, which should be of same length, or if another orientation will take it. There's a one vector is there. The other vector should be exactly of same length and of opposite direction. If this is a vector A bar, this will be B bar. So what we write B bar as minus of A bar. If this is P bar, this is Q bar. P bar will become minus of Q bar. Look at there, both the length A equal to B again. Vector A bar, magnitude of vector A bar equal to B bar or A equal to B. Here, P magnitude of P bar equal to magnitude of Q bar, or just you can write it in this way. Even there's no need to show that arrow and that one. So we just, this will be sufficient, even the symbols. If P equal to Q means P and Q indicates magnitude. So what is a negative vector? The B bar will become negative of A bar, or A bar will become negative of vector B bar. P bar will become negative of vector Q bar. The next one will define the null vector. Null vector. So here, what is a null vector? Whose magnitude is 0 and direction is unspecified. What is use of null vectors? Direction is unspecified or not defined. Direction is not defined. It is. No. So what is the meaning of this? Something I think we should just analyze once before. Okay, there's some block or a box, what will be that? I'll apply one force, 10 Newton. Then I'll apply force here, 10 Newton. I applied this one. So then we know what is the net force will be 0, no? 10 minus 10, they're opposite to each other. The net force, we put it like this, F1 bar plus F2 bar. This will be 10 towards right, the force, and the other one towards left. Anything directed towards right, positive, towards left, negative will take. So this will be plus 10, minus 10, this will be 0. Then how you write that equation? F1 bar plus F2 bar is equal to 0, no? You have to write it, no? So what do you mean by 0? This is also a null vector. This 0 is what here? A null vector. What this 0 says? I am a null vector. That's what the 0 is saying, that I'm a null vector. Okay, this is, I think, very essential for us in simplifying all the mathematical equations which deal with the vectors. So there's a purpose of bringing the null vector here. The 0 says I'm a null vector. Or else what you can write? F1 bar minus F2 bar. Okay, this is about the next we'll go for the unit vectors. So it's a vector whose magnitude is equal to unity, and they are used to specify the direction. It's a vector whose magnitude is unity is a vector. It's a vector whose magnitude is unity and is used to specify the direction. Now, if you take the examples of that, so the rectangular coordinate system, it is having some specific directions here, no? If you look at the rectangular coordinate system, it will have a specific direction. So this is the y, this is z, and this is x-axis. The unit vector that will be directed along x-axis will be I cap. The unit vector that will be directed along y-axis, that is j cap. The unit vector that will be directed along z-axis, k cap. So what is the use of this? Suppose let's say that a person is running with a speed, say like a v equal to around 6 meters per second. Is running along x-axis that you can see clearly. Now, what is the velocity of that person? V bar equal to what we write, 6 meters per second is the magnitude along x-axis. Or this will be more systematically, it can be written as 6I cap unit meter per second. So what do that 6 indicates? Magnitude. What do that along x-axis indicates? Direction. What do this velocity indicates? What do this velocity indicates? This will indicate the physical quantity. What do that meter per seconds indicate? That will be a, what is the left color? Blue color left over. This will be a unit. So that this I'll put in all the colors here. Now look at this. There's a magnitude along x-axis is now I cap. Notice now here. So here, if you expand this, if you really expand this, these are the very fundamental. Please do try to understand. So what is this quantity? Physical quantity. It's a velocity, no? And what do this 6 indicates? Magnitude. Unit. This indicates direction. Similarly, same thing here. If I bring this, so what do this? This particular green color one V bar indicates physical quantity. LO1 magnitude. The pink color one, the direction. And this particular thing is the unit of a physical quantity. So these are the ways in which we are expressing our hope. So what is that? I cap is a unit vector. So what is I cap? I cap is a unit vector directed along x-axis. Let me. What about j cap? Is a unit vector why to write three times? So let me just copy paste it. along y-axis. This will be along z-axis. Just and look at this x-axis, y-axis, z-axis. Fine. So that one specific direction, the along x-axis, 6 meters per second along x-axis. Now I cap has come. Then how we define basically a vector? Vector should be is defined as magnitude direction, or the direction is given by unit vector. So therefore a bar equal to mod of a into a cap. There's a one typical cap will call unit vectors the vector by its magnitude. A vector by its magnitude. I think I'll remove this so that it will be very crystal clear for you. There's a magnitude. There's a magnitude. This is the direction unit vector, and this is the vector. How you define unit vector? Vector by its magnitude will become unit vector. So is it only 3 unit vectors are there? No, it can be n number of unit vectors you can bring. This a cap in what direction? A cap can be in any direction. I think this is something very fundamental, which you must able to understand. So what is the direction of the a bar? A bar can be somewhere in a space. A cap will be along a bar. Or put only a bar. So a cap this one. So for along every vector, the unit vector will be directed along the vector. The direction of the vector will be the unit vector. So how we would define unit vector? Vector by its magnitude. For a given vector, how to calculate unit vector means vector by its magnitude. There's a one very primary thing which about the unit vectors we can go for. Even in circular motion, we do have unit vectors we define. Suppose if a particle moving in a curved path, it will have the velocity. So here we define the unit vectors, one which is tangential, the other one will be towards center. So this will become En cap, unit vector directed radially inward. Some other color. Now, unit vector which is directed tangentially. So the tangential direction I'll indicate by Et cap. The radial direction I'll indicate by En cap. They're also like a Et cap and En cap will become unit vectors. So here A cap is a unit vector. So the unit vectors which are along specifically along X, Y, Z, they'll become I cap, J cap, K cap. After unit vectors, we'll take the next one. Like or parallel vectors. So the two vectors having same direction but different magnitude are called as like vectors. Two vectors having same direction, but different magnitudes. These are the like vectors, we can call it. Now, what about the unlike vectors? Two vectors having different magnitude and different direction. Unlike means where the directions will be opposite, magnitudes will be different. So here strictly A not equal to B, A bar not equal to B bar. Same thing here, A bar not equal to B bar, A not equal to B. So how we change this? Two vectors having two vectors having different direction and also two vectors having opposite direction, we'll write it. Yeah. Opposite direction and different magnitude. They will become unlike vectors. They're just like a simple some primary definitions may not be that specific, or you can say like a very, very important here. After this, co-initial vectors. Two vectors these will become co-initial vectors. So not only two, it can be even more than two vectors here. So where they have same common initial point. If two vectors are having common initial point, there's have to be co-initial vectors, A bar, B bar. Look at here, P bar, Q bar, and R bar. Or they're having common initial point, or the tail of vectors are at same point. This called like a tail, this is a head, this called like a tail, and this is a head. If the tail of two vectors are at same point, we should call that as a co-initial vectors. So here, how we define this in vectors having same co-initial points. So this called like a tail of, so what is this called like a head, this called like a tail. So when you take the vector, this part of the vector is called as a tail. This is called like a head. So for co-initial, what means the tail of the given two vectors or more than two vectors should have the common point. Then you can say they are co-initial vectors. Afterwards, we'll go for collinear vectors. The vectors are in same line or in parallel. They're said to be collinear. So the two vectors, if they are parallel, they are parallel, or they can be like this. Even. We'll show the next. Even if they are opposite to each other. And there's nothing called like a, sir, what about the length? Why you're showing the same length in all? Okay, let's show it little bit different here. I'll give the same example. So if we have lengths equal or they need not be equal. There's not a necessary condition. So all these will become collinear vectors. Coplanar vectors. So vectors lying in same plane. Three or more vectors lying in same plane. So they're said to be coplanar. Coplanar means, okay, we will take the coordinate axis. So look at all these vectors. So in that they will lie in XY plane. So we can call all these vectors as coplanar. Whatever the direction, orientation, we are not bothered. So look at the vectors A bar, B bar, and C bar. A bar, B bar, and C bar lie in XY plane. So A bar, B bar, and C bar are coplanar. They lie in one plane. You can put it in any plane. It doesn't matter. These are some different types. So let me highlight it. So that'll be easy for you to revise. I forgot. So these are the, still we have plenty. We have to. So these are all the type of vector. Let's get into the remaining thing, coplanar. Next we have the position vector. Which will indicate the position of a given point in a space. Later on, we are going to go in detail for this also. There's a vector X, Y, Z axis. So there's a vector R bar, you write it. So there's a point OP, which will have coordinates X, Y, Z. So I'm defining the coordinates of this point P by using a vector. I'll call that R bar is a position vector. So what is the use of position vector? Which is used to define the position of a point in a space. So here OP bar is equal to R bar. This R bar is called as a position vector. So what it does, it defines the position of a point in a space. Again, almost every problem will be dealing with position vector. Okay, after this, we have axial vector. A vector which will be directed along the axis. A vector which is directed along the axis of rotation is called as an axial vector. What are the examples? What we can give? Any examples are there? Okay, we'll do one thing. We'll take the examples like that of fan. This will be dome. I think one fan, I'll know it, then I'll copy. So this is the dome, and the other things, they are the wings. And this will be the sense of rotation, how the omega will be directed along the axis. What is the axis? This will be the axis. About this axis, the fan will be rotating, will be swinging. We do have many axial vectors, so let me just introduce. We are at a very nascent stage, so let me stick on to the only few primary things which you can notice. So what is that arrow indicate? That this arrow indicates the sense of rotation. Then the omega here will be directed down. I think you might have seen the rotating fans. Then similarly, we can take the door. This will be the inch. Okay, let this be the handle. So what is it? That everything is a door. Huh? Now you can rotate this door in either of sense. You can open or close it. So now let's see this. No. So when you are opening it, it will swing like this. The omega will be directed vertically down. When you are closing it, the omega here will be directed along the axis upward. So this blue color one is the axis. And what this is a door. I think you have everyone in your home, doors will be there. Once you open and close it and do make observation of omega, when the fan is rotating, that also check it. What can be the direction of omega? So these are the very general things which are related to our life. Is what you are encountering. Physics is not about something thinking big. Physics is about open your eyes and see objects around you. That's what the physics. You have to try this level. So rather than confining yourself to the book. So make observation of the physical world, and better you want to happen. I suggest you like a better spend. You want to learn physics, go and sit in kitchen. There are so many objects are there in kitchen which are related to our physics, and all the kitchen items will help us a lot in understand the physics very beautifully. No need of research lab. Higher level physics, okay, the basic mechanics what we are studying, no, the kitchen will be more than sufficient. So like this, we have many axial vectors, of which one angular velocities. I'm giving example. Omega is called as angular velocity. It's an example of axial vectors. Okay, next we'll take a free vector. Okay, this will be a free vector. So what is the basic? Let me just define first, then I'll give some suitable examples. Whose action is not confined to or associated with its unique line in space. What does it mean? So we'll directly take one specific example. Let there be a so let this be a truck which is moving along a straight road. Along a straight road as that. Now this particular truck will have velocity vector. After some time, what we see, this truck will be at some other position, will undergo displacement and will be at some other point on a road. And look at its velocity vector. Earlier, the velocity vector was somewhere at point P1 on the road like this. Now it is at point P2. So what is the free vector? Its action is not confined or associated with its unique line in space. Means this vector b bar velocity vector will be at point P1 only. No, it is undergoing displacement. This will become a velocity of a truck is a best example of the free vector. What are the position of this vector now at one instant of time? So let's say that at t equal to 0. Also like at 10 a.m. After some 5 minutes, the truck will be at certain distance. You can say like let it be at a distance of say like a 6 kilometers. Now, where was the velocity vector? It was at some point P1 on the road. No, now after some time it will be somewhere far away. So is it confined to any space? Nothing. No, it's not confined. It is just getting displaced. So this is a free vector. What all the most of the mechanics, the first part of the mechanics what we discuss will be of the free vectors only, like velocity, acceleration. Later part, when we go for the rotation mechanics, they will do some problems on the other vectors called like a bound vector, bound or fixed vector. So what is the basic definition of it? Okay, there's a one body is there. The body will not turn. Also, there's like a bold fixed boulder. Then I'll apply a force on it. Let me apply force. Where I applied at one specific point here. You can see this. I applied a force and it will not undergo displacement. So what is a bound vector? I think this is something very important. We discussed many problems on bound vector here. The initial part of mechanics will be free vector. Later part will shift to the bound vectors. So it's a vector. It's a vector for which a unique point of application is specified and thus cannot be moved without modifying the conditions of the problem. At one specific point, that particular force is applied on a body. So then it becomes like a bound vector or a fixed vector. Means there is a difference between them as here. So for free vector, what are needed? Just I think only essential factors are needed, no? There's I think very only essential factors are needed to define it. What about here? Along with essential factors, and point of application is needed to define it. It's about the free vector, bound vector. Last one more, we have sliding vector. Let me take the directly one example. So I injured these two rods. This is injured here. These two rods are injured like this. And they're connected to a common point. They're connected. So there's a common point. So they're connected here. So now this will have, I'll apply force. I'll apply force at this particular point. Let me apply force F here. So this will become line of action. And after some time, they can also move. No? They'll undergo displacement. They'll undergo displacement, the diagram, the same diagram. You can see, you know, the hinge position will not change. The hinge position will be there as it is. Oh, I think, yeah, it is adjusted properly. Yeah. No. So look at the in position. The in position has not at all changed. The rods are there only. They're hinged here. Look at the point of application of force. It got displaced, but the line of action didn't change. Hope you are able to understand. Earlier, this was the point P1, this P2. Or say somewhere here is what? P2. So the P1 is here. Now this is P2. So where is the point of application? Point of application changed, but line of action didn't change. This is called like a line of action. So then therefore, so what we how we can analyze it? It's a vector. It's a vector which has unique line of action in space, but not unique point of application. And it is having magnitude and direction. So essential are there. And the direction of force doesn't changes. So to define this, what are needed? Essential plus line of action are needed. The direction of force doesn't change. So essential factor. So what is the sliding factor? What are the features? Essential and line of action. Okay, these things are needed here. So there are some free vectors. Need only to define free vectors, you need only essential factor. Bound vector, you need essential and point of application. Then the sliding vector need essential and line of action. Okay, these are all the different types of vectors is what I just introduced. Later part, as we get into the rotation mechanics, there you are going to come across all these examples. Just at least anyway, like rather than just putting some literature, I give some examples. So at least with this, you can understand. Where do you see curtains or two rods connected? It's not something very big, no, this one, all these things. So these are, what are these? These are rods. There's a rod 1, rod 2. I think there are many equipments, or in house you might have seen something, rods connected and moving. There you can come across all these things what we have discussed. Okay, fine. So these are the different types of vectors. The first we define the vector. Then let me just briefly. We had the first we started with the definition of vector. Then we classified physical quantity into the scalars and the vectors. Then afterwards we went for the defining the vectors. Then okay, after defining the vector, what is the big problem we encountered? We encountered like how to deal the mathematics with the vectors, because they're scalars, okay, only magnitude, and we are very good in how to add, how to subtract, how to divide, multiply. What all the algebra we learned, it was all about the scalar, how to add two scalars, how to subtract, how to multiply, how to divide. In the vectors, as we went for the performing some mathematical operation, the directions also involved. How to deal with directions, the mathematics we don't know. So that particular mathematics is what we are trying to bring. That's called as a vector algebra. In physics, we just call this chapter name as vector. So here what we are going to do, how to add vectors, subtract, multiply, how to split, or how to combine. That's what we are going to analyze here. So initially, we have just made some background. What are the different types of vectors, everything. In tomorrow's class, we'll deal with the mass involved with the vectors. Okay, thank you all of you. Okay, kids, like we had the discussion about the definition of vectors and the type of vectors. So you do just analyze, think on them. So don't memorize any of these things because they will not help you. Just if you mere memory that one. I give some diagrams also. With the help of the diagrams, try to understand the concept involved. Okay, these are some in my real life also. I do come across the vector. The best example of vectors, what you can realize is the force. You push some object, nothing but you are applying a vector on that object. And try to compare things and learn so that you'll be in a better position. Okay, thank you very much. Okay, take care, bye, see you.